Hello everyone, Mathematics Wizard here. Today I will be showing you 6 rules for rational exponents. So let's get started. Okay, so rational exponential rule number 1 is called zero exponential rule, and that states that anything raised to the power of 0 is 1. So for example, if you had 3 to the 0 power, that's 1. If you had 5 to the 0 power, it's 1. If you had infinity to the power of 0, that's also 1. So no matter what you do, anything raised to the 0 power is always going to be 1. Okay, rational exponential rule number 2, power rule. Now this rule is divided into 2 parts. So the first one you see is product to power rule. Okay, so for example, let's say you had a simple x to the 5th power raised to the 4th power. That equals x to the 20th power because, again, product to power. You multiply the powers 5 times 4, you get 20. And you have to bring the x to the outside. Now, let's say you had 2x to the 4th power y squared all raised to the 3rd power. Okay, so now it's getting a little bit complex because see, not only you have to multiply the powers of variables, but you also have to multiply the value of the coefficients. So in this case, 2 to the 3rd power, also known as 2 cubed, gives you 8. So now next you have x to the 4th to the 3rd, giving you x to the 12th. And finally you have y squared cubed, which is y to the 6th. So you see how you have to break it up in parts? So you have 2 cubed, which is 8, x to the 4th cubed, which is x to the 12th, and finally you have y squared cubed, which is y to the 6th. Pretty neat, huh? Okay, now we're going to go on to something a little different, but should be a similar concept. Okay, so now we're going to be moving along in the power rule. The second part to this is called the quotient to power rule. Let's say you have x squared divided by y to the 5th raised to the 4th power. Now, this equals x to the 8th divided by y to the 20th. And the reason being is because, once again, x squared raised to the 4th power gives you x to the 8th, and y to the 5th raised to the 4th power gives you y to the 20th. So far so good. Alright. Alright then. Rational exponential rule number 3, negative exponential rule. This rule means that negative exponents in the numerator get moved to the denominator and become positive exponents, while negative exponents in the denominator get moved to the numerator and become positive exponents. Only move the negative exponents. Okay, with that explanation, let me give you a couple of examples. So we'll have 3 examples. Let's say you had 5 negative squared. Now normally without the negative being in the exponents, you would know that the answer is 25, but however, that negative will tell you that the answer will be the multiplicative inverse of 25, which is 1/25. That negative tells you to put a 1 in the numerator. Now there are a couple of exceptions. We'll get to those soon. Alright, second example, you have 4x negative squared. Okay, now in this case, you're going to be keeping the 4 in the numerator. And the reason being is because that's our coefficient. The coefficient is what you keep in the numerator. Now, the x negative squared is going to become your denominator. The reason being is because although the negative tells you to bring a 1 in the numerator, but there's really no need because 1 times 4 is 4. That's why 4 is the only number that's going to be the numerator, sorry. And then the denominator, x negative squared is going to become an x squared. Alright, let's try that with one more example. Alright, this will get interesting. Now let's say we had x negative cubed divided by y to the negative 7th. Now, the way this works is that x and y are going to interchange places. So what that means is, that means you're going to have y to the 7th divided by x cubed. See what I mean by interchange is that x and y are going to change places when you have their answers. Okay. Now, don't forget, you have to make them positive when they interchange places, because when they interchange places, you have to make their powers positive, or else your answers will be wrong. Just a little check. Okay. Alright then, and with that we move on to rational exponential rule number 4, the product rule, which states that multiplying two exponents with the same base, you keep the base and add the powers. So let's say you had, for example, x multiplied by x to the 5th. Now, the thing is, whenever you have an x by itself, automatically its power is going to be 1. So if that ever confuses you, just put a 1 next to an empty blank x, so you don't get confused. So automatically you know that, remember, according to the product rule, you add their powers, or exponents. So 1 plus 5 gives you 6, and you keep the x. So therefore, x multiplied by x to the 5th gives you x to the 6th. Now remember, about the way I wrote it, I know it might confuse y'all. It doesn't matter how I write it. You can write it like this, with a dot, or you can write it like this. It doesn't matter as long as you add their powers. It doesn't matter what you do or how you do it, but as long as the answer is correct. Because remember, x is really x to the first power. So you have to make sure that no matter how you write it, you just have to remember that x is a power of 1 raised to it. So always have to remember that x with no power is automatically x to the first power. Y'all can't forget that. Alright now, last example. Now, let's say you had y to the 4th multiplied by y to the 9th. And according to the product rule, your answer will be y to the 13th, because once again, the coefficients stay the same, although there are variables. The y's stay, and the powers get added. So the 4 plus 9 gives you 13. Okay. Rational exponential rule number 5, quotient rule. This rule states that when you divide two exponentials or exponents with the same base, you keep the base and subtract the powers. This is similar to reducing fractions, but when you subtract the powers, put the answer in the numerator or denominator depending on where the higher power was located. If the higher power is in the denominator, you put the difference in the denominator and vice versa. This will help avoid negative exponents. Yeah, negative exponents. Yeah, I had to mention that because there are like some situations where they might not want you to put it in negative exponential form. That means they want you to put either a 1 in the numerator or any other number greater than 1 in the numerator over its variable or some other term in the denominator. So, let's get started. Okay, first example, let's say you had x to the 5th divided by x cubed. That's a simple x squared because, like I said before, all you're doing is subtracting the exponents. So 5 minus 3 is 2. Alright, now, let's say you had y to the 4th divided by y to the 9th. Okay, now this is what I was talking about with negative exponentials. Now, people are going to most likely do this. Y to the negative 5th. Now, that's okay to have, but to some people, if it like, they want you to be like more specific, they might want you to do this. 1 over y to the 5th. Now, each way is okay, It just, if you're comfortable with it doing it in exponentials, you can. If you're comfortable doing it in fractions, you could do that also. Like I said, it doesn't matter how you word an answer. What really matters is that you understand the concept of how each problem or exercise is done. Alright, one more example. Okay, here comes the big shock daddy itself. Now, x cubed, y squared, divided by x squared, y to the fifth. Now, the answer is going to result in x over y cubed. The reason being is because, easy, money, x cubed divided by x squared is x. Now, whatever variable is farthest to the left, that's what you include in the numerator. And of course, the y's are on the right, so that goes in the denominator. Now, as you can see, y squared and y fifth are going to be y to the negative third, but once again, to be more specific, you could put y to the third, its positive form, in the denominator. So basically, I really could have had this, x y to the negative third. But to be more specific, you put x in the numerator, and the y to the negative third will come to the denominator, putting it in its positive form. Because remember, when you're moving places, you have to put it in its positive form. Alright, on to a final rational exponential rule. Rational exponential rule number 6 is the definition of fractional exponents. And this final rule comes in two parts. Now, for this one, part 1, this says that if the exponent is a fraction, then the problem can be rewritten using radicals. Notice that the denominator of the fraction becomes the index of the radical. Now what that means is that in these examples I'm about to give you, they're all going to have 1 in the numerator. So let's say, for example, we had 7 to the 1/3 power, and they ask you to rewrite this as a radical. So the way to do that is you take your n term, which is 3, and set that equal to the root. Put a radical around it, then take your a, which in this case is 7, and raise it to your m power, which in this case is 1, but we don't really need to write it because, of course, anything to the 1 power is going to be itself, and 7 is already itself already. So we just leave it as the cube root of 7. Okay, next example. Now, let's say you had x raised to the half power. And again, they want you to rewrite it as a radical. So, remember, you take your n, which in this case is 2, set it equal to the root. So in this case, it's going to be the square root of, you're going to take your a, which is x, and set it in the radical. And of course, the m is our 1, and as necessary. So, it becomes the square root of x. And yes, that was an error. That 2 wasn't meant to be written there because obviously known that any number missing in the root spot is automatically declared as the square root of. So yes, radical x is exactly what it is. Okay, one more example. Okay, let's say you had 23 raised to the 1/5 power. Okay, they want you to rewrite this as a radical, so before, you take your n, set it to the root, then you take your a, which is 23 in this case, you put it inside the radical. And our m is 1. And there you have it, the 5th root of 23. Okay, we're now going to go on to part 2 in the definition of fractional exponents rule. Okay, so part 2 in the definition of fractional exponents states that if the exponent is a fraction, then the problem can be rewritten using radicals. That's the same as the previous one. Notice that the denominator of the fraction becomes the index of the radical, and the numerator becomes the power inside the radical. The last part, numerator becomes the power inside the radical, means that we're going to be having numerators greater than 1. Okay, so our first example is going to be x to the 2/3 power. Now, So the same rules apply. We take our n, which is the 3, we set that equal to the roots. Our a is x, and our 2 is our m. So we put that on the outside. So there you have it. Our answer is the cube root of x squared. Okay, next example. Let's say you had 5 raised to the 3/4 power. So, you take your n, which is 4, set it equal to the root. Our a is 5, and our 3 is our m that goes on the outside. So our answer is the quart root of 5 raised to the 3rd power, or cubed. So basically that means the 4th root of 5 cubed. It really doesn't matter how you say it, but once again, as long as you get the concept, you'll be okay. Alright, time for one last example and we'll wrap it up. Okay guys, here is the big shock daddy itself. Alright, now let's say you had y raised to the 3.5 power. Alright, so in this case, we already know that we see a mixed number in the power, but don't worry, if you just relax and I got you. Okay, so the same rules still apply. Our n is our 2, which is the root. Now, our a is the outermost, that's going to be our y, that's going to be on the outside. Now, our n, our m is going to be, what do y'all think? Yes, you guessed it, it's going to be 7. Now, the reason being is because 3.5 is similar to 7 halves. I kind of made it funny. I was trying to get y'all to think. See, the reason why I did that is because it was going to get a little tricky in the end. But if it was a little difficult to figure out, I got you. So 3.5 converts to 7 halves. And of course, you do your rule. Your n is your 2. That's going to be in the root area. And once again, you'll have to put it because automatically it's defined as square root. So you really have to put in the 2. It's unnecessary. Our a is our y. And the m is 7. It doesn't really matter where you put it. You can choose to put the 7 here, or you can put it on the outside. It really doesn't matter. But yeah, I put 3.5 in there to get y'all. But don't worry. Y'all will get through it. Y'all will get it soon. Okay. Well, guys, I hope you like this video. And if you do, I would really appreciate it if you give me a like, a comment, and subscribe on this video, and tell me what y'all guys think about these 6 rules to rational exponents. I'm very looking forward to seeing these comments. So thank you very much.